Greetings everybody. I would like to show you this problem that I've copied directly from my math lab. We're given this function here, and notice it has different parts to it. There's three formulas, and which one you use depends on what the x is, and that's called a piecewise function. But we're given that function, and then there's various questions that follow, one of which is to identify the graph. Okay, so I'll show you how to graph this from tables and points, which is the most basic, simplest way you could graph it. Okay, so there are three formulas, like I said, and each of them applies to different x's. Like if you're going to plug in x's less than -2, then use the first formula. If you're going to use x's between -2 and 2, then use the second one, and so on. So it's like that. It's on a case-by-case basis. So I'm going to use each formula with the x's that are appropriate, get a few points, and then draw the graph that way. One thing I notice is that either by looking at these formulas or the graphs that are given, each of these has a shape that's a line, and you only need 2 points to draw a line. 1 point's not enough. 3 points is more than you need. Okay, so let's take 1 minus x if x is less than -2. Okay, so here's that. So into 1 minus x, I put x less than -2. I'll just use 2 points. I'll use two convenient numbers. I always use the endpoint, -2, and then maybe one other point. So -3 is less than -2, and then I'll always use the endpoint -2. I put in -3 into this formula, I get 4. I put in -2, I get 3. Okay. Now, an additional detail is, as I go through these, if the inequality is strictly less than or greater than, this point will be open on the graph. The reason, well, I'm really not supposed to put in -2. It says the x has to be less than -2. That doesn't mean equals to -2. It just means less than. So I'm not supposed to use that, but I can as long as I leave the point open. So it's a perfectly fine way to draw the graph. So I get 2 points right there, and notice, like, here's my graph. This is the graph I'm going to get. I plotted them. -3 for x, 4 for y, that's this point. -2 for x, 3 for y, that's this one that you see open right there. Okay, now to the next one. That formula said if x is greater than or equal to -2 but less than 2, use x plus 2. So I always use the endpoints, and I just need 2 points, remember, because all these are lines. So I use -2 and 2. That's 2 points, and I'm supposed to use the endpoints when I do this. So okay, -2, if I put it into that formula, I get 0. I put 2 in, I get 4. This one's not open, that one is. Why is this one open at 2, 4? Well, because 2 right there is associated with a, it says 2 is greater than, or x is less than. Anytime you get less than or greater than, as opposed to less than or equal to, greater than or equal to, you will get an open point. So then I would plot those. First point, -2 for x, 0 for y, that's this one. Then 2 for x, 4 for y, and there it is, open. Okay. All right, one more. Remember, this last part says just -4. That's not a typo. Maybe you'd expect to see -4 plus x or -4x or something like that. It's just -4. But that's the, like, I would say, the simplest of all kinds of formulas. It just says for any x greater than or equal to -2, the y is just going to be -4 all the time, no matter what. So if x is 2, y is -4. If x is 3, y is -4. If x was 5 or 6 or 10 or whatever, y would still be -4. So, all right, there's those points. 2 for x, -4 for y, 3 for x, -4 for y, and they're all going to be solid -4 from there on out. So there's our graph. We can recognize it as choice B right here. Once I look at mine and compare it to those, it's pretty obvious at that point. One more thing, maybe you're inclined to keep this line headed that way. It stopped at that open point. Why did it stop? Well, because it said that this first formula, this first line, this first part of the graph was just for x less than -2. -2 is right here. It's not going to go past that as a result. So that's why this one stops there, This other one starts here, but it stops there. And this last one starts here and continues indefinitely. All right. So that's how you draw the graph. Next part was some limits. Okay, so I'm asked to do the limit as x approaches -2 and 1 and 2. So -2 is over here, and I see that at -2, the graph is disconnected. All right. So this is called a jump discontinuity. And whenever that's the case, the limit does not exist. In other videos, I've explored this kind of thing by making tables and comparing the numbers on the table, but for now, I'll just say whenever we have a discontinuity like that, a jump discontinuity, or one piece of the graph does not connect to the next one that follows it, the limit there won't exist. So that's why it doesn't exist at -2, right here. The next one, what's the limit as x approaches 1? Well, 1's right here, and I get this point right there on the graph at 3. And there's no disconnection there. There's no jump discontinuity. And so since, x is 1 gives you y is 3, then for the limit, if x was anywhere near 1, y would be close to 3. The limit's 3. Okay? So that limit has an answer. The last one, the limit as x approaches 2. Well, 2's right here, and that's again where there's a jump discontinuity. This piece of the graph does not end where this one picks up. All right? And so I said earlier that at that point, 2, or any other point, if there's a jump discontinuity, then the limit won't exist. So that's our answer for the third part. Okay, so here I wanted to do a combination of things. I would like you to know how to sketch the graph real quick. And even if you didn't draw it, you could at least recognize which one of these was correct based on how I told you to do it. And then once you get that, I think the limits follow pretty easily.